big focus of the engagement activity has been to have occasional online seminars. We became very familiar with those in lockdown. The model and the technology has advanced in parallel, and we're very pleased with the outcomes of that. So this is the latest in that series of online seminars, just sharing information, allowing space for discussion and debate as well. So introducing our topic this evening is Professor Sean Smith, and he'll be accompanied by Julio Bros-Williamson, both attached to the University of Edinburgh, with which I've got connections still. But I would like to therefore hand over to Sean, and I've arranged for both Sean and Julio to introduce themselves in a lot more detail than I just have. But Sean, over to you.
Thanks very much, Gordon, and good evening, everyone, and many thanks indeed to you all for the opportunity to present. So I'm Professor Sean Smith. I'm Chair of Future Construction in the School of Engineering at the University of Edinburgh, and also Director of the Centre for Future Infrastructure, which is based in our Edinburgh Futures Institute. And I'm joined today by Dr. Julio Bros-Williamson, who's a lecturer here in the School of Engineering, and also Chancellor's Fellow for Net Zero Buildings. Our main focus of today is looking at delivering net zero and beyond for buildings, estates, and archetypes. Just to say that we will also supply all the slides as a PDF through the organization. And also there are some slides, because given the limited time for presentation, because we want to do Q&A afterwards, we've also hidden some slides in this presentation, but which will be in the full PDF deck that you'll see. So it's a kind of part one and part two between myself and Julio to discuss a range of aspects. And so if I may, what I'd like to do is just crack on very quickly, because there's so many things to discuss and cover. We'd like to get into the Q&A with yourselves quite soon. When we look at some of the challenges faced vis-a-vis not only climate change, but specifically the net zero targets, we really have a high complexity and high density issue when we look at our major cities. And today we're going to be looking at some comparisons and analysis of what's happening also north of the border in Edinburgh and Glasgow. And you'll see soon, they share a lot of similar characteristics with London. The diversity of building users and occupant needs is obviously quite key. Grid capacity restrictions, which have been in London for quite some number of years, predominantly actually since before the 2012 Olympics, and really haven't lifted very much in London. And that's obviously creating some issues vis-a-vis as you start to move into this electrical powered and switch from gas and various other bespoke and other elements. Today we'll look at archetype approaches, which Julio will discuss in part two. And within the context of, as we look at large cities, particularly complex cities, the sourcing of that waste heat, which is available and when tapping into, there's a lot of competition for that, for community and district systems, the heating systems for the future. And that's creating a kind of multi-user concentrated demand. There are further issues coming down the line in terms of the acceptance and accreditation of novel solutions. As we look at our buildings, as we look at our estates, there are new types of fabric insulations and new heating technologies coming. And of course, these have to be piloted first, but then they have to be accepted and accredited. And so the timelines for those can also impact on how quickly sometimes we may wish to actually put in a new solution. The historic and listed status of many of your buildings and across many buildings in the UK, none more so than the University of Edinburgh, which has 580 buildings. It has 25% of the entire Scottish University's estate, of which 495 of those are heated buildings and 170 of them are listed buildings. The retrofit investment finance, which has been in big discussion over the last 18 months to deliver these works, is still ongoing. And it'll be interesting to see how pension funds and others move forward as they invest into long-term financial models on retrofit. But we're all coupled with the same issue of the pace of CO2 reductions and our skills capacity to engage for mass retrofit delivery. And I'm going to touch on that today. And of course, specifically for London and for the southeast of England, it's not just warmth, it's also coolth. And as a result, the technologies which parts of the country are looking at will be predominantly in higher areas and lower areas respective to technologies as they need. So let's just look at London, Edinburgh and Glasgow, three amazing cities. When we look at flatted buildings alone, London is 54%, Edinburgh 68%, and Glasgow leading in the UK with the greatest proportion of flats of any city at 73%. That, when you take into account the UK average is roughly about 21% for flats. Scotland's particularly high because of the way our cities are built up in concentrated areas. We're at 38, 39%. But England's about 20, 21%, Wales 13, and Northern Ireland about 10, 11%. All these cities are also looking at energy plans, community and district, both place-based within local authorities, within the boundaries of various parts of cities, some looking at community district heating, and also some looking at individual building solutions for heating and cooling and some of the new technologies. But there is also a wonderful role of our existing underground infrastructure and how we might look at some of the solutions and how we integrate those heating and cooling solutions coming forward. The utilization of rail networks and the embankments. If we're going to put in district community heating systems, then in effect, we're not transporting gas or hydrogen. So does that create a safer conduit for if we're using heat instead within these pipe networks? Should there be discussions with Network Rail and many other organizations to try to see if I could utilize some of the land availability and embankments and other things to put in these new pipes? And maximizing that existing infrastructure routes for low carbon heat, which I'll touch on shortly. And all three cities share a 2030 net zero target. So Edinburgh, Glasgow, and London are sharing that very, very difficult timeline. If I may, and as I say, you'll get to see these slides afterwards, but a few months ago, back in November, I was presenting at the International Retrofit Conference, and I was discussing the timelines both for Scotland's 2045 net zero and the UK and European 2050 net zero targets. And we often kind of think, well, it's 22, 21 years away. We have plenty of time to 2045, or it's 27, 26 years away till 2050. And that might lead us to, if we take the UK context of ours, we like to think, oh, we've got plenty of time, 236,700 hours roughly of work time since November of last year till November of 2050. But of course, you take away the weekends, the Friday afternoons when the construction industry doesn't work, and also you take away the holidays, Christmas periods and everything else, and before you know it, you're down to 137,000 hours. But then, of course, we don't work 24 hours a day. We typically will work about 8 days. And even if we take a 10-day typical working day where we have a 10-hour day, we're 1 hour traveling in, 8 hours work, 1 hour back, we're left with about 45,302 hours, which isn't a lot of time, which is equivalent to about 62 months. But if we look at the timelines for 2030 for London and Edinburgh and Glasgow, we actually only have, if you accumulated real time available, about 1,377 days or 33,000 hours. And that's a 24-hour clock. But in reality, we have 11,000 hours. So we have 11,000 hours by 2030, which if you packed all those hours together, it's only 459 days of full-time activity. And of course, there's a big focus on Plan A, net zero. More recently, we've seen various organizations, including our own universities, looking at a Plan A plus, which is taking things beyond net zero, otherwise known as net zero plus. And that includes things like biodiversity and various other aspects. But what's becoming hot on the heels of many discussions is if we don't hit Plan A, and we're not sufficient with Plan A plus of going beyond net zero and looking at biodiversity and various other aspects of circular economy, if, for example, the temperature differential moves far too fast, and it seems to be moving faster than we'd all planned, then what are we doing for Plan B? And these are the things that we also need to look at, sadly, is if we can't hit Plan A and hit net zero, how much resilience and adaptation should we be building in right now? And there's a short article here with a link of an article I wrote looking at, could we actually devolve or develop a Manhattan Project hashtag too, not for an atomic bomb, but could we use the same scenario of how we brought together all the very best of industry and scientists, which happened with the Manhattan Project, but actually bring that into climate change and speed of delivery. A bit about procurement. As you share yourself across the delivery group, there are many organizations that will want to be looking at procurement. And I just wanted to touch on the role of procurement to deliver net zero. We had a recent scenario 2 or 3 years ago where effectively across the 32 local authorities in Scotland, they were going to be spending in the region over the next 4 years of about £800 million of retrofit. That was 200 million per year. So it seemed crazy for all 32 local authorities at that time to actually undertake individual procurement strategies for what would be similar buildings or similar approaches. And so they amalgamated this together, and we helped set up this energy efficiency contractors framework for procurement with an organization called Scotland Excel. And it's been incredibly award-winning in what it's been able to achieve, and its reach across so many SME companies in the delivery of retrofit solutions. The role of new technology obviously has a play. Our behaviors are key to what we do, but we will also rely on new technology. It's great to see we have improvements in air source heat pumps, new heat and energy storage systems. There are new battery technologies that are reducing the risk of fires, which come from thermal runaway, which is great. But when you look at the targets ahead, Scotland will require, for example, to retrofit 145,000 homes per year, England 910,000 homes per year, and Europe almost 12 million homes per year. And this creates an issue because we have parallel synergetic demand on similar construction materials and low carbon heating systems. And we are very dependent very often on importing such energy systems and solutions. The upside of degassing the grid, just as an aside, is if you just in housing, that's not the non-domestic buildings, just housing, in the value of recycle value of copper gas pipes from UK homes, it's equivalent of about £230 million of copper that will be brought back onto the market by the degassing of homes. There are some new technologies coming. These can be applied both to houses, but also to non-domestic buildings. They can be stacked and racked. And one of them is a British UK innovation called Heatwave. And the world's first trials of this will be coming out very soon. And we'll be involved with those trials along with some other universities. It has multiple advantages over many other systems that are on the market. It's only a half-day install. It doesn't require fabric first treatment, unlike air source heat pumps, which also will typically take about 4 days to install. It's very quick installing training for trainers coming in, but importantly, because you can link it with battery connections, it can help smooth the grid demand because you can draw down the electricity and power at night, which is far cheaper, and then it operates just like a normal boiler system during the day. And this is a British company, and these will be coming very soon. When we look beyond just our existing buildings, the other aspect to consider is what are we doing with any new buildings? And so here we've put ourselves to the test at the University of Edinburgh, where we're building a brand new School of Engineering building. And whilst the original conceptual designs were brought out in 2017, in 2020 and 2022, we then revamped the design to look at, one, how we could reduce the type of materials that we were using and reduce the embodied carbon. That's how much carbon was involved in the manufacture of those materials. But importantly, what we decided to do is we know that there are still new technologies to come for heating and also cooling. So what we've decided to do is we have built a net zero laboratory space, or are building this as buildings being built live, where adjacent to the main plant room of the building will be a space where we can test new technologies, but also when the timing is right, we'll be able to switch and bring in new technology into that plant room and connect directly to the building from that net zero laboratory. So in essence, we are trying to plan for future retrofit by creating a design in for change in this new building. There's a big discussion that often goes on energy efficiency fabric. That's the thermal performance of the envelope of the building and the amount of energy and carbon we're utilizing to actually manufacture these materials. And as a result, air source heat pumps are relying more heavily on such fabric improvements. There are new air source heat pumps coming for flatted buildings, which are going to be trialed in the UK very, very soon. But there is, we think, greater work that needs to be done on the potential sweet spot where you can limit the amount of fabric or envelope improvements you're making to your building, but still deliver the air source heat pump performance. If we don't take such measures and approach it in such a way, the likelihood is we will be on a big burn period, as I describe it. Our electricity is predominantly not renewable. There's still a lot of gas and other aspects which are utilized to create our electricity. And so to make all these products and everything else, we're actually on a big burn to actually make them before we install them. And could that actually be counterproductive to the targets of where we're going? Some really complex issues for us all to consider. Just before I hand over to Julio, there's two things I want to touch on. One is historic infrastructure. So here in Edinburgh, for example, we've highlighted the underground tunnels, which are available in Edinburgh, which haven't been utilised for many years, except for tourists. And one of them is a Scotland Street tunnel you can see here with cars. It's currently lying empty, but a potential huge opportunity for the Newtown Georgian part of Edinburgh to actually have large battery storage or district community heating pipe network put in it without disrupting the roads and infrastructure around it. And so we can crisscross 1.3 kilometres of the city by just using that existing tunnel. And similarly, underneath the old town, there are tunnels which also haven't been used, which could be utilised and save us digging up roads and other things. I've stolen this image from the ICE, the Institute of Civil Engineers website, but again, we've talked about, and other people have looked at, the ability to use waste heat from sewers. But not just that, perhaps there's an opportunity to also use the major sewer pipes, elements of them, where we can actually integrate into them district and community heating pipe networks, again, without digging up the ground, and again, accelerating that delivery of low carbon heat and networks installation. I just want to finish off, if I may, on skills before I hand over to Julio. First of all, London, like the southeast of Scotland, faces major issues. It's a very fast-growing region, like London is with population and other things. In the southeast of Scotland, we have a huge amount of workforce that we need. And so when we're looking at how are we going to deliver the scale of demand that's coming both in retrofit and net zero delivery, we worked with our local colleges to map out all current supplies of skills. What are the future needs we're going to need across the low carbon sectors on skills and workforce delivery? What is the replacement need also as people are retiring, and running that, looking at 1 or 2 or 3 different technology scenarios for skills and what we would need. And when we did that, it was a fascinating journey, looking at the propensity of what we would need to do. And this then formed a focus for the southeast of Scotland, and I'm sure London is doing the same, of looking at the formation of a net zero accelerator hub. And why is this important? Because within the studies that we did and looking at the CITB reports, that's the Construction Industry Training Boards, we found that whilst in, for example, Lanarkshire, the middle column there's plenty of workforce also in the southwest of Scotland, and in Tayside on the far right, shown in green, there's lots of additional workforce. But in fact, the southeast of Scotland is really, as it were, sucking on that resource. It's pulling it in, which is why our roads are clogged with so many construction and other vans in the morning, is because the southeast of Scotland has been growing so quickly and there's so much work. We are drawing and needing the skills surrounding us. But the issue is that these other local authorities and other regions, as they develop net zero, they will also require to deliver their own works. And as a result, they will use their own workforce. So we need to replace it. And that led to the formation of this proposal to have an integrated net zero accelerator hub of new investment for new training facilities, linking our 4 regional colleges, and to drive forward that push on skills. And just finally, we've produced just recently a research bid, and we can certainly keep you informed. And this is to look at net zero high density buildings. We will find out in June or July if that funding comes through. But we hope that the solutions that would come from this new centre for net zero high density buildings and the solutions coming forward, we would be able to share across the whole of the UK. I'm now going to pass to Julio, who's going to share his screen.
Thank you, Sean, for that. It's really set the tone for some of the slides that I'll be presenting, and certainly trying to look at more of that, the kind of practical and technical methods that we've been exploring here at the university and with other stakeholders across Scotland and certainly across other areas down south as well, with some discussions. And certainly this problem of accelerating the delivery of this work, and how do we practically and technically achieve some of these elements of reaching the net zero carbon potential and also the performance of our buildings. And certainly looking at that technical approach, we've been looking at identifying building archetypes as that vehicle to bring that aspect around buildings, and how do we actually reduce the demand of energy? How do we reduce and reach some of the carbon targets that have been set for them? So there's great potential there for using and applying building typologies This has been done in other kind of forms in practice, looking at grouping architectural styles of buildings, certainly the intended use and also the age of these buildings, to recognize how they operate or recognize other solutions. And that is a similar ilk that we're kind of taking forward. But essentially, one of the aspects and one of the reasonings around this is to conserve the buildings and the built environment that surrounds us in towns and cities, because there's a big merit of rescuing and keeping a lot of our historical and existing buildings around us for the kind of conservation and historical values that they present. Certainly some of the social and economical elements that they surround the cities, but certainly some of the more environmental thinking around carbon emissions and climate change mitigation. And examples around here, certainly here in Edinburgh, buildings that deserve and have that kind of historical context. This example here on the left with the Mavis Bank House, a kind of neoclassical example that's been long derelict and abandoned. But we've got some very positive examples through some other kind of buildings that have been rescued and upgraded and retrofitted. So certainly there's a lot of value there. And we've got certainly lots of buildings that are kind of in that transition phase between being rescued and reused. Here in Edinburgh, we've got the old Royal High School that's been lying there vacant, and there's been lots of proposals that have been rejected over the years, but certainly a lot of value there historically. And the same goes for Egyptian halls in Glasgow, very prominent architectural features there that have been also kind of not put in adequate use. And many buildings across the country in our cities are in this situation. Some have been rescued, luckily, and have been saved from being demolished. Some kind of recent examples here in Edinburgh is the old Royal Infirmary, which is now our new Edinburgh Futures Institute building, here part of the university in the city, that has been transitioned from an abandoned and derelict state to a fully functional educational building. And the same goes for our Edinburgh Climate Change Institute, which has gone through a host of retrofits and reuses, trying to stop and rescue these buildings from demolition, which has been kind of quite eminent in a lot of our buildings and towns. So some of our current thinking and some of our work has been turning around categorizing and trying to come up with ways in which we can technically deliver the improvement of buildings, trying to rescue them through that way. And one way has been to adopt an archetype approach, where we're looking at delivering retrofit through clustering and grouping building types, which, I mean, not always can be captured fully, but we feel that's a method to take forward. And categorizing previously has been gone through, certainly in a domestic and a non-domestic way of buildings, through maybe the building configuration, for example, having archetypes through the types of building, whether they're detached, semi-detached, flatted, etc., and also on its building use, whether they're commercial, industrial uses, etc. So that's kind of on a grander scale approach, and we're trying to maybe look at different commonalities in the building solutions, looking at ways in which there can be shared knowledge and shared methods of retrofit through a simplified shared solution. And we feel that the method of construction way of archetype distinctions is a way forward, where we can have some shared and commonalities in ways in which we can implement retrofit and reduce energy wastage through that. So it's really looking at that, expanding at different building uses. It's looking at these subcategories and categories that could be arising. Some of the current methods are looking at the construction types, primarily the wall method of construction as that trigger to giving us that information on how they perform and also how we can improve them, thermally speaking. And we know that a lot of our buildings, existing buildings, can be categorized in different wall types, from solid stone to cavity brick to timber examples. Certainly some regions will have more prominent building types and methods than others, but they could be definitely clustered around. And this can pave the way also to delivering low carbon heating measures, also meeting some of the energy performance certificate bands and improving these, and certainly reaching out to some of the net zero performance and some of the targets. So we're proposing looking at the archetypes in these different methods of construction, but certainly looking at what's been done before in terms of insulation as being one of these, one of the steps forward in improving the thermal performance. In Scotland, we've got, through the House Condition Survey, a whole range of data that gives us more information on what's been insulated, what hasn't, and that's given us some indicators of what needs to be done. And of course, some of the difficulties that we do have is the wide variety of different subcategories of even the same building, but we feel that the method of construction can narrow these down to deliver the technical solutions for retrofit. So expanding on this a bit further, the method of construction, there are a lot of shared kind of knowledge that could be brought in terms of whether they are domestic or non-domestic wall types, because we know that there are non-domestic buildings that have adopted similar methods of construction as domestic, so that we can some shared knowledge and definitely some shared indicators of how that can be delivered by building owners, by estate managers, etc. There are other components that will be around for questioning, and solutions need to come in. For example, for floors, for different window configurations, for the roofs, etc. But there are some equal solutions that could be shared amongst these, as long as they're very clearly identified and delivered in a design and also performance way. So facilitating bulk retrofits is a way that we're trying to bring in the use of archetypes, and understanding that there's these commonalities between them and that the solutions could be shared and added in a larger scale. And certainly trying to look at this, the low-hanging fruit in a lot of these, and the building archetypes can definitely provide that. And separating maybe some of the easier retrofits and some of the building methods of construction that could be upgraded easily, and also isolating and maybe looking at ways in which these harder to treat or harder to retrofit buildings can also be detailed in a better way. We've been doing this not just with the building envelope, so the walls, the floors, etc., but equally we've been trying to do this through the low carbon heating delivery and the needs that this can present to buildings that can be quite varied in some circumstances. But again, there are shared knowledge there that similar building types and archetypes can be replicated in other building types. And we've been working very strongly with Scottish Power and Scottish Energy Networks, where they're trying to look at the technology out there and preparing a series of pattern books together with our envelope archetype solutions that could be assigned to these different building types and can easily be rolled out and can easily technically be assessed. So there's ways in which the retrofit can be rolled out in this way. We know that some of the buildings need that specific building surveys. That doesn't negate the need for these, but understanding that there is a lot of commonalities that could be replicated, and that's where the work is kind of centered around. Now, to gather a lot of the understanding of this, we organised last year a series of workshops addressing the domestic, the non-domestic and the historic buildings, and looking at all the issues, all the challenges that have been presented by building estate owners, by individual building owners, and also by homeowners to really understand what complexities there might be, what differences there might be between the different building types. And this was a very kind of interesting way of discussing some of the solutions as well moving forward. So we had a very successful set of workshops, over 160 participants from different groups, from local and central governments, some architects, engineers, but very interesting from general public as well, with that interest to saying, well, how can I actually retrofit my building or my home to really do this in a more efficient way and an informed way? We produced a kind of summary paper which once these slides are shared, hopefully you've got access to the link where we host this, where we just gather a lot of the thoughts, a lot of the discussions from the stakeholders, and that could be a good read for yourselves to kind of take that and apply it to your own stock or your own buildings. But really it came up with 3 key recommendations, looking at implementing robust systems and coded archetypes, looking at creating a publicly accessible pattern book and guides for different archetypes for people to roll out and to understand how to retrofit their buildings. But something that Professor Smith has been developing as well is looking at that UK national building database, where we can integrate archetypes onto that to get a shared knowledge of how buildings are built and what types of buildings we have across the UK. So applying these archetypes can be very easily transferable over to non-domestic buildings, as I mentioned. There are a lot of kind of commonalities there. In previous iterations, a lot of the energy performance on non-domestic buildings was very ropey. It wasn't very clear. Therefore, there weren't any specific kind of needs for building owners to kind of accommodate themselves within the targets. But it's getting much more stringent. Legislation is trying to bring in a lot of these existing buildings into an energy efficiency demand side assessment, and certainly looking at surveys of buildings and condition surveying and maintenance being a big factor. So we feel that the archetype approach can be easily adopted, where we look at fabric and we also look at low carbon technology in delivering these. And obviously we have a mix of users within these buildings and larger building estates, a lot of different activities in these. It's not as clear cut as housing, but also there's some complexities around historical kind of past retrofits that also a lot of these buildings go through. So just a bit of a flavour on some of the work that we're doing here with larger non-domestic buildings at the University of Edinburgh campuses. Professor Smith has explained the extent of our campuses across the city of Edinburgh, specifically looking at surveys and categorising all the building types that we have across the campuses, and looking at ways in which we can survey a cluster of them, understand how they currently perform, and come up with different ways in which various components can be retrofitted and improved thermally. So, for example, walls as a primary example, but then also looking at windows and other openings, flat roofs, which pose quite large problems, and coming up with different solutions that are suitable for that specific archetype. And we'll be sharing some of the slides on that. But I think something that really resonates across the campuses that we have and other stakeholders is the way that we scale this up. We typically start with a building level assessment, where we look at individual buildings. We understand the complexities of one building on its own. But in reality, we need to be thinking across the way into larger data sets, larger buildings that connect with each other. And the campus level approach is a primary example, where we look at a scaled retrofit approach. We're looking at master planning. We're looking at that diversity of the state. But also it links into the city level, where it can be linked to other stakeholders like the NHS, like other users and other large states that are around cities, where there can be shared knowledge around the delivery of envelope performance and retrofit, but also low carbon heating solutions like networked heating between communities or district heating solutions. And just to kind of finalize here, I think it's very much around the art of the possible in a lot of the solutions that we come across, certainly around the non-domestic occupied buildings, where we're trying to balance the costing, we're trying to balance the carbon and energy savings, and also some of the disruption that might arise here. And there's really identifying that sweet spot where it could be suitable in different points. And it's not always about energy savings around that. It's also about the cost and that balance between these, and balancing other kind of reasons and other challenges like climate strategies, like looking at risk around an occupancy, trying to find funding, etc. So that's important. So just to conclude and hopefully move on to some of the discussion, certainly a lot of the archetypes, they're not your only solution. It's not a one-size-fits-all approach. It's certainly one way of looking at a building retrofit, but certainly looking at that commonality and ways in which it can be rolled out. The Archetype solution can be a good guide to do that. There are building limitations, regardless of all the similar archetypes, and certainly doing specific surveys on specific areas of certain buildings, certainly some of the ones that are very bespoke and there's key features around them, is something that should be looked at. Something that also Professor Smith touched on is that strategic kind of national approach, looking at the peak demand through storage of energy. Also behavioural changes around the occupants of these buildings is key, and striking that balance between the cost of fabric first, looking at the envelope performance, but also the reduction of energy consumption and that upgrading and where we link into some of the existing networks of energy. And that risk of what comes first. Is it the fabric first, or is it that network capacity? And is it going to be a race to hooking up that kind of low carbon electrical grid that that's being rolled out throughout the UK? And for maybe information for those of you who deal with larger estates, and maybe for smaller estates as well, this could be a good action stage approach for assessing your stock and looking at ways in which you can apply the Archetype approach. So I would certainly ask people to determine that kind of method of construction and placing it within our Archetype. That's predominant around your estate, identifying variations and subsets and maybe areas that need a bit more attention and survey. But equally looking at benchmarking that archetype and looking at ways in which other data can give us that indication of performance, understanding the net zero potential on where it sits, and also looking at other ways in which a pattern book can be adopted to show best practice and guidance to that. Applying a similar approach to low carbon heating and solutions, and also re-evaluation and looking at ways in which design of these retrofit solutions can be assessed, and looking into low carbon heating and costing also as an option. We're open for any questions.
Absolutely, Chief Julio. Thank you very much indeed. And Sean, of course. I'd like to kick off with a question using Chairman's prerogative, and that is, the principle of archetypes, generic solutions, pattern book solutions seems so self-evidently a good idea. Has there also been any quantification of the time that would be saved, nationally, in coming back to Sean's introductory comments about just how much time we've got left? Have you been able to make a reasonable assessment of time saved if archetypes as a principle were adopted as a key platform for delivering net zero? And a follow-on from that, what are the blockers to being able to deploy this on a large scale?
I mean, firstly, in terms of, we've been here before, folks. And England took the world lead. So back in 2002, 2003, a pattern book was developed for Part E of the building regulations, which I led. And that's a completely different area to do with sound insulation. And that was where new house building wanted to build. They all wanted to make a step change, make an improvement and enhancement of performance, but they needed to know how to get there. And so from a series of testing and pulling in of data from all sorts of sources, we were able to produce the start of a pattern handbook, which is called Robust Details. And I still serve on Robust Details as technical advisor. But it's now created 400 combinations that architects can now choose. The time-wise spent, the big value was up front. It was the design stage. It was the de-risking. So the value of the pattern book also is then in the skills process and the project management, the site management, because from a productivity standpoint, it's better. We can slightly reduce the time on site because people are now doing repetitive works, they're understanding that process, but the big time saving was up front at the design stage, at the specification stage. And we also then at that time assessed the carbon savings, and they were significant, particularly on the reduction of waste materials, which uncommonly, if you're going building by building by building and doing every one individually, etc., not coming in as a collective, your waste materials tend to go up. And that's one of our great fears with the retrofit journey. I think the construction industry has reduced significantly its waste streams, but here we are with mass retrofit about to embark. And if we don't use a kind of pattern book approach where we can, the likelihood is we will have greater opportunities or disadvantages, should I say, of higher waste streams from smaller sites.
I think one of the blockers is that kind of race to carbon, and there is a big pressure to just think about the carbon aspect, and sometimes that's not the only element, and there needs to be kind of a thought around the users, the occupants. So often a lot of building owners or building managers go for the quick carbon reduction, which at the moment is applying the low carbon heating technology. And it's not always the best solution just to look at the low carbon heating solution and technology as a first instance. So there needs to be that reevaluation of the building type, and hopefully the archetypes element facilitates that discussion to say, well, the priority is fabric or the priority is technology. And that's where I think there could be some good discussions moving forward.
And just on that note, we shouldn't take away that Letty, for example, in London, the organisation there has been looking at, a pattern book approach, and other organisations have too. There's also the National Retrofit Hub, which is starting to look at this. But in a sense, there have been many opportunities to kickstart this, and there's many people out there who have data on particular archetypes of what they've done, but there hasn't been a national pooling power to bring all that data together.
Faye.
Hi, I was just wondering, are these pattern books, is this work available in the public domain? Because there are several groups I'm connected with that this might be quite useful to offer to, and I don't know how accessible it is, how much I can share and those sort of things.
Certainly, firstly, on the current project we have at the moment, this proposal bid is to now go and collect all this archetype data to kickstart a handbook for key archetypes. So that's not publicly available at the moment. We have spoken to a number of building owners, housing associations, other organizations who are willing to come forward and give their data and put it in a standardized format, which is great. And Julio and I currently have some live projects on some of the, what we call the grand challenges of retrofit, where we're actually testing and evaluating archetype solutions live right just now. Julio's been out grabbing quite a bit of that data. But the aspect is, unless there's a centralized pooling of that, then I think it's still going to be a bit scattered. And that's why our proposal to the UKRI is to bring all that data together where we can, as quickly as we can. And also provide the door open. When we first developed robust details, for example, what happened there was it was very generic approached, and then we realized there was a number of new proprietary products or technologies, so we could then open the door to them too.
Victoria's a school governor in her spare time. What should be top of the list for the next property committee meeting?
Well, I'll go first and I'll hand over to Julio. Great question. So first of all, it's baselining all energy that you're currently utilizing and where is it coming from and what is your potential heat losses in the property estates and your current operational energy. Then to assess, and I'm not sure if your school has a listed status, but if it has a listed status, then my first port of call would be to discuss with the planning authorities if there's any guidance on what you are permitted to do to the external fabric. And this is an ongoing issue in Edinburgh. Just to example, we have the Newtown Heritage Trust, we have the Coburn Association, lots of very valued organisations that have supported the heritage of these existing buildings. But previously, any guidance on secondary windows or other aspects was held in kind of some sort of website, which was a membership organization. And what the city council, so the organization is trying to do is to create a new public facing focus of information. So anyone in any particular building in a historic building can access that common ground. And then I'll hand over to Julio now, who'll probably talk to you about energy.
Thank you, Sean. Yeah, I mean, it's energy and carbon. I would definitely look at energy and carbon benchmarking. So once you've collected that information of how it operates, looking at how off you are from the benchmarks of similar buildings, because that gives you an indicator of whether you're in the best or performing on or the kind of high performing buildings. And that would definitely kind of give you an action plan to saying, right, okay, is my building envelope leaking? Is that the first point of call? or is it an assessment around my heating system and ventilation system? What are these kind of low-hanging fruit, which I mentioned earlier?
Yeah. I should add that you might be able to access funding also, depending on the type of building that you have. There are some fundings out there to help with retrofit. And one aspect to look at is if it has a low EPC, Energy Performance Certificate. So if it's an ERD, there is sometimes available grant funding for you to get that up to a B. Now, if you can at least target a B, cost-wise, that's going to be more effective. These could be quite more simple measures, but some of the grant funding may be more, depending to target an EPC band A, but the cost rises significantly as you shift up those bands.
Another question posted from this one from the Master Water Conservator, Martin. It's Martin Biggs. Great presentations. Why the resistance to these new initiatives? Is it funding or short-term thinking by local or national decision makers? And follows up with, is it easier in Scotland than England?
Well, we have separate building regulations in Scotland and have done for over 300 years, and separate planning restrictions, although there are many, many similarities north and south of the border, thank goodness. But in that regard, I'll give you an example. We first proposed, there was a fantastic formation actually led, to be fair, by the local authorities and the Housing Association in Scotland. I received an email back in early 2021 asking me to join a ZEST task force. I thought it was a bar of soap to begin with, having it's the only word I knew of ZEST, but it turned out to be the Zero Emission Social Housing Task Force. And it brought together all registered social landlords. It was fantastic, absolutely tremendous. And Scottish Government helped facilitate the meetings, the civil servants. But what was very interesting was in 7 weeks, they pulled together a wonderful report of how we need to tackle our housing. Intense meetings over 7 weeks, through about almost 2.5 months. The report was produced, but then it took a year for the government to then respond, who then produced a report, a counter report, and suggested, oh, we could do this. And we suggested archetypes. We suggested, look, we could do this very, very quickly. And yes, one could say, what are the barriers? It's lack of progress, lack of momentum, lack of joined up thinking that happens in many governments, not just here. Different incentives. Italy has an amazing incentive called the super bonus. You may have heard of it. So basically, if you own a building in Italy, and you're going to retrofit to improving the energy efficiency, doesn't have to be to net zero, but they will give you 110% of what you spend. So if you spent £10,000, they will give you £11,000. Of course, it'll be euros. And the rationale for that was it was to create an incentive for people to crack on with that kind of work. Obviously, when they put the call out, the funding got gobbled up very, very quickly. Germany's released £4 billion in retrofit monies, all again absorbed. So I think we need to quicken the pace, centralize, coordinate better. We have fantastic knowledge in this country right across the UK. And in terms of the future national buildings database that may be coming, that's the Department of Energy Security and Net Zero that are leading that pilot. And it's UCL, University College London, who are looking at a pilot for non-domestic buildings for a national buildings database. Now, of course, because it's driven by the Department of Energy Security and Net Zero, it's energy focused. What we're saying to that government department, and UCL is in agreement with this, is we need the material contents, the construction contents, the archetypes, think about health and safety. There's no national record of asbestos in the UK, there's no national database. Could you incorporate all of that and hit so many stones at the same time, or should I say birds, but let's call it stones because it's buildings. But what an opportunity we have ahead of us if we could pick up that pace.
If I may just say, one of the barriers that I've experienced is very much dealing with occupied buildings, which is not easy to decant. Certainly, a lot of public buildings and certainly housing. So that's a complexity. How are we going to deal with the rollout of a lot of this work when these buildings need to remain, in a lot of cases, occupied? So that's definitely something that needs to be ironed out in the future.
Hand up from Jason.
Thanks, Gordon. My pressing question is the procurement information, the procurement hub that you set up. Is that only available to Scottish public authorities, or is it available to any UK public authority?
So the actual procurement hub was set up on behalf of the 32 local authorities. They had requested that. and they approached Scotland Excel, which does procurement frameworks. So there was previously, many years ago, an energy efficiency kind of procurement framework for works, which some local authorities had used. And it was felt that what they'd like to do is revitalise that, but now looking at net zero and bring in all the local authorities. So that one is specifically for Scotland because it's the funding related to that. But the model behind the procurement framework, how it was set up, is literally on a shelf, which Scotland Excel has. So if, for example, parts of London's local authorities, councils, boroughs, or Delivery Action Group were saying, we're going to procure a lot of work in this area, it may be worthwhile to contact Scotland Excel and say, well, what if you set up an energy efficiency procurement framework for us? Because there's something already sort of there, the boundaries of it, the structure of it. So it could be duplicated quite easily. But one thing is, it's been wonderful to see the SME companies take part in it. It's not just the big players. And when you think that 92% of the construction industry companies are SMEs, and it's 50% of the workforce, we have to take them with us on this.
Indeed. That's probably a nice one to finish on, Sean. You've sown a seed of thought. Livery Climate Action Group doesn't have any authority to procure anything for any of the individual member companies, but we do have a lot of member companies, as I mentioned at the start. If they're all of a similar mind, they could potentially collaborate. Ladies and gentlemen, just a round of applause for Sean and Julio for a fantastic presentation and lots of food for thought. Thank you very much.